Hello, good morning, my Chemistry 11 students. How are you today? I hope you guys have a nice weekend, enjoying the really warm weather, and also have a good time celebrating Mother's Day with your mom. So, thank you all for tuning in again to another lesson by me. And yeah, it's already almost middle of May, so we'll see how things are going. So, I might be seeing some of you in June. I don't know. I will be, I'm sure we'll be getting more information in the next few weeks in terms of how things goes. But for now, let's have another lesson, offline lesson like this. Um, so just want to start off the day by talking about this little, message here on your screen. I know like it's hard to get super motivated when you are just at home, nobody is with you and the weather is so nice outside, and it's hard to get motivated to learn on your own. And now this is a good opportunity for you to know, to see whether like offline, online learning it will work for you because you've been trying it for the last few weeks. But either way, I hope you guys are giving your best shot, because like whatever knowledge that you gain, it's yours, right? It will be useful for the rest of your life. It's an asset for yourself. So keep learning. Some people get this message, knowledge is power, knowledge is yours to keep forever. Some people get it really early, and that's why a lot of people are really motivated to strive to get good marks, to learn as much as they can. But some people, for some people, it takes longer time for them to get this message. But doesn't matter, I'm hoping that by repeating it, eventually you will get it, you will understand it. This is, you guys are like 17, 16, and this is the prime time to learn, to absorb as much as you can. And don't waste this time, because like when you are at my age, you will realize that it's like it's so much harder to learn. And I'm sure you heard that before. People, oh, I learn it, I forget it easily. And like our brain, it's programmed that it's there's only, you can only be youthful for a certain period of time. So don't waste it, learn. Okay, learn as much as you can. I know playing is fun, you have a fair share of playing, but learn as much as you can. All right, so last class I started a lesson on organic chemistry. Organic chemistry is a unique branch in chemistry. It's if you're gonna take more chemistry courses in your future, you'll be just taking like several courses just on organic chem. So again, organic chem is study of carbon, right? Organic means study of carbon. We are organic being. We are made up of carbon. So you will be if you going into university, that's what you'll be studying in several courses. For me, I really like this area. I think is really fun and it's very unique. Everything you learn in chemistry mostly is in organic chemistry. It's not to do with carbon. So in also in Chem 12, you won't have another chance to study organic chem. But I think it will, if again, this will serve as a good foundation for you guys to learn more chemistry in the future. And again, it's, I think to me is really fun and very interesting to learn as well. So last class, I gave you guys, no, this one, the 10 alkanes, right? So you guys learn about alkanes. So again, alkane is just the ends in ane, right? That means it has single bonds between carbons. Okay, alkanes, ane, and all the 10 alkanes, they all end in ane, right? So you should definitely memorize this list from methane, 1 carbon, all the way to decane, that means 10 carbons. Okay, um, so I hope most of you finished this sheet for homework from last class. I'm just going to go over one with you. Like I said, some of you may find skeletal structure a little bit hard to do. I will show you a program that I found. That's super neat and also easy for you to understand skeletal, and actually, in fact, it's really helpful for the rest of the learning in organic chem. So I will just do one with you, and then I'll show you that program to show you the 3D model. So I'm gonna do heptane. So hepta, you guys know from even grade 10, hepta means 7, right? So to do the full structure, that means you have to draw everything, right? So you're going to draw 7 carbon straight. So that's 5, 6, and 7. And now you're going to add in all the hydrogens. So remember we did Lewis diagrams before, like carbons, like I mentioned before, they carbon like to have all share pairs. Carbon do not like lone pairs. So for like if you can see it from the alkanes, you can see that carbon like they all have they can they all connected to something else. So in this case, they all connected to hydrogen. So sometimes if I get lazy, I'll just stop like this to draw the full structure because each stick represent one hydrogen. Okay, so here you see the hydrogen here, but if I lazy, sometimes you will see me just stop like this, and which is okay. Okay, but here I'm going to add in all the hydrogen. Okay, and for the formula, I'm sure you guys can calculate it yourself. C7, right, and then calculate um, 2m plus 2. So 2 times 7. So and that will be 16 plus 2, 16. Okay, so C7H 2 times 7, so 16. Okay, 2 times 7, 14 plus 2, 16. And for the condensed structure, so you will see the carbons at the end, they have 3 hydrogen, right? So the way to do it is I'm just gonna space it a bit small for me. So CH3 at the end, like this. And then sometimes you can do a stick, but if you really, don't feel like it, or it's not mandatory. You can just ignore the sticks, okay? So CH2 here, and CH2, all the middle ones are CH2, right? All the single bonds. So that's 5, 6, and the N at the end is CH3, okay? So that's the condensed way of drawing heptane. And remember, for carbon, it's the bond is between carbon and carbon, right? All the bonds here is between carbon and carbon. But here, when you draw the condensed way, it looks like as if the hydrogen is connected to carbon, but that's not true, okay? You should know that that's not true. Um, so that's the condensed way. Now the skeletal way, here so these two, the first two are not, they don't have it because it's too short, okay? So the um, propane has 3 carbons, okay? Propane has 3 carbons like this. So each one of these dots in the middle here represent 1 carbon, okay? So that's the structure of propane. Now I'm going to show you this program and it will make sense to you really clearly how how to draw the skeletal structure. So this program I already put it on your class notes. It's called Moville, moville.org. So it's already on your class note on the OneNote. So you should. It's really easy to use. So I'm just going to demonstrate. So here on the left-hand side, you see all these single bond, double bond. So now on the bottom here, they have this carbon chain because I'm going to draw carbon chain. So I'm going to use this one on that says carbon chain on the bottom. Okay. So I'm going to draw heptane. So heptane has 7 carbons. So just gonna let's see. Oops. Oh, it shouldn't be like this. Let me try again. Okay. Huh? Oh, I thought it's showing me as the chain. How come it's not showing me as the chain? Oh, that's odd. Yesterday when I was using it, it wasn't like this. Let me try again. Still learning how to use this. Okay, try again. Huh, weird. Now it's not working for me. Okay, I'm gonna pause here and I'm gonna resume in a sec. Okay, so I'm resuming here. I'm try to figure out how to play with this program. It worked for me really well yesterday, but it seems to be a little bit harder today. So anyways, I'm gonna draw a heptane, okay, 7 carbons. So again, I'm using this one, the carbon chain on the bottom. So let's give it a try. One carbon, two, 3, 4, 5, 6, 7. Okay, so as you can see, like this program, when the carbons are connected this way, they actually go in zigzag. I'll show you exactly why in a sec. So that's 7 carbons. And now for this button here on the top, you can actually add in the hydrogen really easily. Okay, so it looks like this. Um, so all the carbons at the end has 3 hydrogen, right? The middle ones it has 2, and the reason they like to be in zigzag is to avoid the repulsions, electron repulsion between the hydrogen. So the way they arrange here, it's the best orientation. It's hard for me to show it to you unless I usually in class I will have a model like all those like little balls of atoms. I can do a model for you to show you how this is why this is the zigzag way, but for now I just have to use program to show you. So here the button on the top here, 2D to 3D, so click on that. So really quickly you will have a 3D model of heptane. Okay, so again 7, too bad it's not color, but it's it's the big one, the ones in the middle, these are carbons, okay? The white ones, they are hydrogen, okay? And the unique thing about this program is actually you can rotate it. You can turn it around. You can move it in different direction, okay? So I encourage you guys to use this program, and when we're going to learn naming today, it will actually really help to use this program, okay? So 7 carbon straight, and so again, why when you draw the skeleton structure, all you need to draw is the carbons, add the carbons, okay? So you can see the zigzag. So carbon, 1, 2, right? 3, 4, 5, 6, 7. Did I count too many? 1, 2, 3, 4, 5, 6, 7. Oh, actually, I didn't make a heptane. I make a octane. But anyways, you get the idea. Okay, so all these zigzag ones, they represent the skeletal structure. Okay, so now I'm going to go back to OneNote and to finish that skeletal structure for heptane. So for heptane, so you can just start with 1 carbon. It doesn't matter where you start on the top here. Oopsie. So 1 carbon, 1, 2, right? That's 1, 2, 3, 4, 5, 6, and 7. Okay, so that's like, yeah. So 7 dots, make sure you just count enough dots for heptane. And that's how you draw skeletal structures. So just a short way of drawing chemicals, okay, organic compounds. So there are different ways you can draw the whole thing. You can draw the condensed way, you can draw the skeletal one. And for the questions you'll be seeing later on, you will be seeing all different kinds. Okay, so let's moving on. So now you know the 10 alkanes, okay? You memorize the structure, um, how many carbons for each. Now we're going to move on to our today's lesson on alkyl groups, okay, and to name branched alkanes. So the alkanes that you are seeing today, yesterday it's like a straight alkane, okay. So 1 carbon methane or 10 carbon will be a decane. So that's a straight chain of alkanes. But today you're gonna see some branch ones, okay? And you'll see some like weird words that in organic chemistry, the word that you're learning today is called alkyl groups, okay? So alkyl group basically just came from a branch chain of alkanes, okay? It's just like, a shorter, like a variation of the word alkane, okay? Alkyl group, okay? So alkyl group is alkane branch, which is made up of only hydrocarbons. So I want to show you how to make a branch to make an alkyl group. So all you need to do basically, so you should have this notes ready, right? Um, all you need to do is to remove an hydrogen from an alkane and it becomes a branch form. Okay, so I'll show you an example. Let's just do um, methane. So for example, just gonna do it here. So if for methane it's CH4, right? So if I'm going to remove a hydrogen from it, it basically becomes CH3, okay? And so, and then it lost one hydrogen, and then it will be basically have a branch that's attached to someone else, okay, something else. So for example here, just going to draw on the side. So again, methane is CH4 like this, right? Four hydrogens. So by losing one hydrogen, so it will basically become CH3 like this. Okay, so that's why I have this little stick here to represent that, it's going to stick to something else. So it still have the three hydrogen, um, and then it will have, a chain that's attached to another branch. Okay, so that's how to make an alkyl group. And then to to connect this alkyl group to the main chain to another to a alkane chain, basically you just need to again remove an hydrogen from alkane and then add the branch at that spot. Okay, so I'll show you in a set. So I'm going to go through this example with you. So here we have, you're going to add the branch ethane to pentane. Okay, so now again, how do we make make a branch ethane? So ethane is two carbon, right? C2H6, and another way of drawing it is CH3, CH3. Okay, two carbons, CH3, CH3 for ethane. And to get rid of one hydrogen, so both of these lose a hydrogen, so it will become CH3, CH2, and then now you have a branch attached to it like this. Okay, so just lose a hydrogen. I just lose one of these ones here. Okay, so now that becomes the branch. Okay, so that's step number one. It becomes the branch form for ethane. So now I'm going to add this ethane group to pentane. So here I'm going to draw pentane. So pentane has five carbons like this, right? So I'm just going to complete it with adding all the hydrogen to it. So let's do it quickly. Now for this branch chain, there's a couple choices where you can add the, actually no, not for this one. So not for pentane. But anyways, so for this, I'm going to remove a hydrogen. So actually, I'm just going to make it shorter. So this is pentane. So for pentane, I am going to remove this hydrogen. Okay, so step number 2 here says to add the branch chain, you have to remove a hydrogen from the alkane. So for this one, I'm going to remove this hydrogen right here, where I have the cross. Okay, so now remove a hydrogen. I'm just going to redraw everything. So I have 5 carbons. Now here you see I'm just adding the sticks here without drawing the hydrogen. So this spot here, I lost the hydrogen, right? So at this spot, I'm going to add this branch chain. So I'm going to add CH2 and CH3. Okay, so notice you have to add the CH2 because CH2 is where you have this stick. Okay, so this stick is where you join to the main chain of pentane. Okay, so this is how you, instead of having a straight chain, now I added some branch chains. Okay, by adding branch chain to it, it basically changed to a completely different compound. Okay, and today we're going to learn how to name these giant, weird looking compounds. All right, okay, so I added the methyl, this branch chain, um, the branch ethane right here, okay, to the main chain of pentane. Okay, so now I just introduced to you to two side branch chains. So the two alkyl groups that we just talked about is from methane to CH3. Okay, so from CH4, I lose one hydrogen. It becomes CH3. Okay, so that's the branch form of methane. Now you need to know the names of these guys. So for methane, it's the the straight chain, right? It's just one, actually this one just one carbon. So you're going to change that to the ending YL. So we call it methyl. Okay, so that's why we call these side chains alkyl groups. The alkyl groups ends in the ending AL. Okay, sorry, not AL, YL. And from methane, you're going to change it to methyl. Okay, methyl. So I'm going to give you guys a minute. You guys can pause it here and try to finish the rest of this table. Okay, figure out the names of these branch names. Oopsie. Okay, let's get started again. So hopefully you guys, you know, took the time to complete this table. So let's check your answers here. So anything ends in ANE, methane, propane, butane, you change it to YL. So the new names now is methyl, ethyl, propo, and butyl. Butyl. Okay, so again, you're learning a new language today with the organic chemistry. So methyl, ethyl, propo, and butyl. So now we're going to learn how to name these giant branch chain alkanes. Here are a couple rules. Okay, so I summarized it here. It might feel very, confusing at first, but when we go through a couple examples, it will make more sense to you. Okay, so this is where the fun part begins. Okay, so here we go. So number one, find the longest continuous carbon chain. So I recommend you guys get a highlighter. Okay, so like what I just did, and highlight the longest continuous carbon chain. Okay, so this longest chain is called a parent chain. So it's called the parent hydrocarbon. Like I just call it parent chain. And so that parent chain goes from basically well, actually not, can't really have one carbon, but goes from you know anyways, all the 10 alkanes, so methyl all the way to decane. Okay, so you need to memorize those 10 names. And by the way, for the side chain, we only have these four because once it gets too long, it won't it will become the longest parent chain. So these side chains, those are the only four we have. Okay, so it goes from very short ones like this, methyl, and the longest one we have is 4 carbon called butyl. Now, and then number two. So once you find the longest parent chain, you're going to number the carbon in the chain. Okay, so it goes from 1 to whatever, 1 to 10, whatever, and start at the end nearest to the first branch. Okay, and so you want to give the branch the lowest possible number. Okay, so I will go over this. It will make sense very soon. And then number three, you're going to name and number the branch. Okay, so the branches we talk about here again is these four. Okay, so that's number three. And last step, number four, this is where you put everything together and you will have the number of the branch chain, okay, and then with the dash, okay, in between, so that always a dash between number and words, and the branch name, which is like methyl, ethyl, butyl, and so on, and then you're going to put the parent chain, the parent at the end, the name of the parent, okay, so that's the parent chain. So again, it's not making any sense to you, I know, so let's do the example here. So get a highlighter out. Okay. So so the example here, you have so basic here, I just need to fix this a little bit. This stick here should be pointing toward this carbon, the second carbon here, and then everything here is like stick together like this. Okay. So this is our first example. Now, step number one, you need to find the longest continuous carbon chain. Okay, so that will be your parent chain. So I'm going to ask you guys to get a highlighter out and then highlight the longest unbroken carbon chain. Okay, so now I know this is your first time doing it. The first time you do it, you will be like, oh, I'm going to just highlight this. This is my longest continuous carbon chain. But if you think about more closely, this is not your longest chain. Okay, so if we go just horizontally like this, you will have 1, 2, 3, 4, 5, 6, 7, 7 carbons. But I'm going to tell you this is not the longest. Okay, because remember these models, these molecules, they are a three dimension, like they are like in a three-dimensional space, right? So you need to think about, like, the way we draw it is like 2D, but in fact they are a three-dimensional molecule. So take a look at the longest chain. It actually goes from here and go across like this, and this becomes your longest unbroken carbon chain. Okay, and so now what is your side chain? What is your branch chain? Your branch chain is right here, CH3. CH3 attached to the main chain here. Okay, so your step number one, the longest chain, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbons. So 9 carbons right here. So therefore, you should know 9 carbon chain is called nonane. Okay, so that's the carbon chain. Now, step number two, you need to number this longest chain and give the lowest number, the lowest possible number to the branch. Okay, so basically for this question here, you have two options. You have two options. You can name it from this way, 1, 2, 3, right? Or you can name it from this way, 1, 2, 3. Okay, like this. Okay, and this would be give you a 4, right? And this 5, 6, 7, 8, 9, like this. So for this branch chain, the CH3, this methyl group, it's located on carbon 4. Okay, now you can try the opposite way. You can go from this way. I'm going to use it green. 1, 2, 3, 4, 5, and 6. Look at that. If I do it the other way, this way, the green way, the side chain is located on carbon 6. Okay, so based on rule number 2, you want to go with the red color. Okay, because you want to have the substitution of carbon at carbon 4, and so this is the lowest number for it. Okay, so the branch name, it's CH3, so that's a methyl. Okay, so now we have all the information. We can put it together. So to finally write down the name of this weird looking hydrocarbon molecule, so you're going to do this. Okay, the methyl group, it's at 4 position. Okay, the 4 dash, and the branch name is methyl. Okay, and the name of the longest chain is nonane. Okay, so this is in one word, no space. Okay, so everything we concluded, this is 4-methyl because this methyl group is on the 4th carbon. 4-methyl nonane. Okay, nonane that represent this longest parent chain. Oopsie. Okay, so I hope this makes sense. It kind of gets a little bit weird, but you will get the hang of it. If you got what I just did here, I encourage you guys to pause the video and try the practice. Just a couple questions here on page 219. There's some exercise practice questions on hapten. So try these couple questions, and then check the answer keys on the back and then resume, okay? Because we're going to move on to something harder now, okay? So now let's move on to something that gets a little bit more complicated. So we're gonna name something that has multiple branched, okay? So more than one branch, more than one alkyl groups. So there are rules summarized on the Hapton textbook, but here I have summarized a couple of them for you guys as well. So if there are more than two alkyl groups, you're going to list them alphabetically. Okay, alphabetically means, like ethyl is going to be actually butyl is before ethyl, right? And then methyl before propyl. Okay, so name all these guys alphabetically. And you're going to precede each alkyl group by its number to indicate the number of its location. So same as what I did here, the number here for the methyl group is 4. So if there are more, all like different side groups, you're going to have multiple numbers to indicate their locations. And again, you're going to have a dash, okay, like the dash here to put between alkyl group and its number. Okay, so same thing, same rule applied as before, all these 4 rules here, and then you're going to add on to this additional rule here. Okay, so we're going to follow our rule number 1, which is to find our longest chain of carbon. Okay, so for this example number 1 here, you have this look no this giant model here molecule here, and I'm just going to add in the lines here. It's missing a few lines. Okay, so um, so you're going to use a highlighter to find the longest continuous parent chain. So for this one, there's a couple options, right? Like, oh, you can try going this way, okay, and count how many carbons. That's 2, 4, 6, 7. That's 7. Okay, so I'm going to tell you that's not the right answer. So try maybe just go straight like this. Okay, go straight like this. You have 8 carbons. So that would be the longest chain. Okay, so now you are going to try to give the alkyl group. So these are the branch ones, CH3 and CH2, CH3. These are our branch chains. You try to give them the lowest number. So you can either go from left to right or right to left when you count the numbers. Okay, so I'm going to tell you, well, you can take a look. You can go from 1 on this side or you can go from 1 on this side. So this one's pretty obvious. You should go from left to right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so go from left to right. So your methyl groups is on the 2nd carbon. Your ethyl group is on the 4th carbon. Now put the name together. Ethyl before methyl. Okay, so we're gonna do the ethyl first. So it's 4 dash ethyl. That's the location of the ethyl group, and then with the methyl group, and then we're going to have more dash because uh, you have a number here 2. Okay, so methyl group is in 2 position, 2 dash methyl, and then the longest parent chain it's 8 8, right? So 8 is octane. So there you go. Okay, so notice no space here because for if it's just letters, you put everything together. Okay, but if it's number and letters, you have to use a dash. Okay, so the name of this guy is 4-ethyl 2-ethyl methyl octane. Okay, so yeah, it's not that bad, isn't it? Yeah. Here, try the next one yourself. Pause the video and see if you can come up with the answer. Okay, so highlight the longest parent chain. So there are 2 ways of highlighting this one. Okay, so you can highlight it this like this, or you can, so that will give you again 8 carbons. But if you highlight it from the bottom and this way, and it's also 8 carbons. Okay, but either way, it doesn't matter how you highlight it, it will give you the same number. It will give you the same answer. Okay, so because again, this is a 3-dimension molecule. And I really want to, let's see, I want to quickly show you this on on MoView so you can see the molecules clearly. I know the lecture gets a little bit long today, so I apologize for that. But you know, you guys, again, you're not doing this. You know, you can separate the video and take a break and come back, right? So I'm just gonna erase this thing. Okay, so I'm going to draw the octane first. 2, 3, 4, 5, 6, 7, 8. Okay, so that's octane. And here I'm going to add in the methyl group. So here, methyl here, one carbon, and then ethyl like this. Okay, so this is the example number 2, and now you can add in all the hydrogen like this. Okay, um, so I'm going to transform this to 3D so it's easier for you guys to see. So take a look. Look at this giant. It's kind of hard to see, isn't it? Now you can try to locate the longest chain by there's different ways to locate it. You can go from because they're on here. You can start with in the middle. So I'm just gonna have you guys rotate it so it's easier for you guys to see. Let's see it this way. Um, mm, okay, like this. So in the middle here, 1, 2, 3, 4, 5, 6, 7, 8. Did I have extra carbon again? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I put an extra carbon again. Hi, silly me. I'm going to erase this one at the end. Okay, and try again. There we go. So if you take a look at the longest chain here, let's count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the longest parent chain. And now like the side chains here, you can see how I put them on the right hand side, or I can put them on the left hand side like this. Okay, so if I follow the drawing, so it's on the left hand side, but it doesn't matter. You see this methyl group here on the bottom, this methyl group CH3 is on the third carbon, right? And I have another ethyl group here on the top. You see here, it's also on the third carbon. Okay, so you see the longest chain is octane. And if you look at the left to right or right to left, it doesn't matter. If I put it this way, right, um, it's still the same. My branch groups is still on 1, 2, 3 on the third carbon here. Okay, so it's 3 methyl and also 3 ethyl. Okay, so I hope you guys can see it. If not, play with it at home. Um, Try to follow what I draw and then just click this button 2D to 3D, and then now you'll be able to see this this molecule in the real 3-dimension space. Okay, so the methyl group again is on the third carbon. This ethyl group here is also on the third carbon. Okay, so now let's go back there and then name it. So I have the longest parent chain, octane, and my position of this carbon here is 3. So alphabetically, I'm going to start with ethyl. So 3 dash ethyl, 3 dash methyl, and between methyl and octane, no space, methyl octane. Okay, done. Let's move on, guys, to the next one. Oh, this one is missing some dash as well. So CH2 is attached to this one. That's on my side chain here. That's that. Add some sticks here. Okay, so now you locate your longest unbroken parent chain. We're almost done. Once you get the hang of this example, you can do it really quickly. Sometimes with some mistakes, because sometimes people highlight the wrong parent chain. So for this one, if you highlight it, go straight like this, I'm telling you that's incorrect. Okay, so try again. Erase that. So where is it? Where should it start for the longest parent chain? So if you go like what I just did, and that would be only 9 carbons. Okay, straight like this. But I'm going to tell you, if you do this correctly, you should start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbons straight like this. Okay, and now you can circle your alkyl groups, your branch chain. So these are your branch chains. So there are 3 of them. There's methyl, ethyl, and propyl. Propyl goes after methyl. Okay, so with ethyl, and then methyl and propyl. So now you need to number the chain. Okay, so should we go from left to right or right to left? Left to right or right to left when you do numbers 1 to 10. So for this one, yes, you're correct. It should go from left to right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now you have the position, then you're going to give it to write down the name. Okay, so ethyl first. Ethyl is F5, 5 dash ethyl dash 3 dash methyl, and then dash 6 dash propyl. This is a long one, isn't it? And decane. So when you try to use that program, the mole view, I'll encourage you to start with something simpler. Start with the previous example, like this one, example 1. You will have a better understanding of how things looks like, and try to move it around and why this methyl group is on the 4th position. But if you do a giant one like this, it might be a little bit like harder to see, because just like there's so much going on. Okay, so that's the name of this giant. So a couple more examples, almost there. Now sometimes we have the same alkyl group repeated. Okay, so you have more than one methyl, more than one ethyl, and so on. So what are you going to do? So you're going to use these prefixes. So the rules are, there are two. You're going to list each carbon number where the repeated groups are attached, separated by comma. I'm going to show you what that means. And then you're going to use these prefixes. If 2 is di and 3 is tri, and so on. Okay. You should know this list from grade 10, but now you need to memorize it. Okay. So I'm going to write down example here, and we'll do it together. Okay. So let's start. CH3. I'm going to do the condensed way. CH3 on the bottom here. CH2, CH, I'm gonna draw a CH3 up here, CH, CH3, CH2, CH2, CH3. So I'm just drawing it the condensed way because it's easier. And now always rule number 1, step number 1 is to highlight the longest parent chain. Give it a try. Okay, pause it if you need it. So for this one, it goes like here and go down, guys, okay? Because that will give you the longest parent chain, like this. And you're going to circle all the side groups, okay? In this case is CH3. So there are 3 CH3, okay? And they are all at different location, okay? So now you have to make a decision. You have to start number. Should I go from left to right or right to left? Again, you want to give them the lowest number, okay? So if I start from left to right, then I give this methyl group 2. Okay, so that's a very low number. But if I start from here, 1, 2, 3, and 4, and the first one here, it will be like 4th position. So I know that is we have to start from left to right. Okay, so number 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now you are going to follow the rule here. Each carbon number where the repeated group is attached, separated by commas. So we have methyl 2, comma, 4, comma, and there is one on the 5th position, 5. And because there are 3 methyls, it's going to be tri. Okay, so trimethyl, and then the longest chain, 8 of them, so that's octane. Okay, so let's look at how interesting it is. Very systematic. You get to, know the exact position of each methyl group, and it tells you like exactly there are 3 of them. Okay, very logical, very, you know, um, systematic way of naming these organic molecules. Okay, isn't it fun? I think it's really fun. Let's do another one that's a little bit more challenging. 2 more to go, guys. Almost there. CH, and I'm gonna put a side chain here, CH2 and CH3, and CH2, CH, CH. So for this one, it's quite obvious. The longest chain, you can just go from one end to the other end like this, and there are exactly 7 carbons, okay? And all these side chains, there's an ethyl here and 2 methyls, okay? And for this one, left to right or right to left when you do the numbering. And yes, it should go from right to left for this one. So I can give the lowest number 2 for the first methyl here, right? So 4 and 5 and 6 and 7. And start naming it. And now alphabetically as well. So we need to do ethyl before methyl. Okay, so the ethyl is on the 5th position. So 5-ethyl and then dash. And there are two methyls. So 2 comma 3 dash. And there are 2 methyls di methyl. Okay, 2-methyl. And then the parent chain heptane. And again, the alphabetical order applies to the actual branch name, E and M. Okay, so not the prefixes. Okay, so even if we have a D here, di, it does not apply to it. We have to go with the branch names. Okay, so E before M. So that's it for the naming of these giants. And I'm going to do one that's opposite because on today's homework, you are going to be doing, you need to be given the name and you are going to draw the structure. So this one is from your homework 9A. For today, I'm just assigning the homework. It's already on OneNote. Again, 8 and 9. And 9 is the opposite. Draw is like you given the name and you have to draw it. So for this one, it's 3-ethyl, 2 comma 3 dimethyl hap. Oopsie, where did it go? Dimethyl hexane. Okay, so once you understand how the name works, it's actually pretty easy. So I'm going to encourage you guys to start with the parent name. Okay, so the parent name is hexane. So you're going to draw 6 carbon like this. Okay, just draw the condensed way. Don't fill in the hydrogens yet. Okay, and you are going to, you can decide from left to right or right to left in this case, but I have the 3-ethyl here. So remember ethyl, it has to be CH2 first and then CH3, okay? So that's where this bond is attached to the carbon. So that's ethyl. And then I have 2 methyl groups on one on the, so for this one, I'm just naming it 1, 2, 3, 4, 5, 6 like this. Okay, so my methyl group is one is here on the 2nd carbon, and then one of them it's I'm just going to place it on the top here on the 3rd carbon, CH3, like this. Okay, so now you added in all the methyl group. I'm just going to clean this up a little bit. You added up all the alkyl groups, the branch groups. You're going to just finish this diagram by adding the hydrogens. Okay, so you can either add it the long way or the short way. It doesn't matter. If you're going to add the long way, you're just going to add it like this. Okay, so this one have 4 bonds, right? So just add the hydrogens like this. Okay, and then here there's 1, that's it, and then 2 here, right, like so. Now if you don't like to do it this way, you can just do the condensed way. So I'm just going to show you the condensed way as well. So you know the first carbon here on the left, you need to add 3 more. So you just need to add CH3, okay? And here you need 1, so add H. And the third one has 4 bonds already, so no hydrogen is needed. And here you need 2, CH2, CH2, and CH3. Okay, so again, if you're not sure how many to add, it's best to draw the sticks and you count the sticks. They should have 4 sticks, right, for each carbon. Okay, so that's it for today. I know the lesson is a little bit long, but I think this lesson is so important. It serves as a foundation for a lot of the namings we'll be doing in the future, and it's always go by this very systematic types of of ways of naming the molecules. Okay, so I hope you guys understand what you are doing. If not, just go back to any point of the video and try the example with me again. And again, for homework, you have the 8 and 9 to practice, lots of questions to practice. Get the highlighter out and practice and check the answers on the back. Okay, so if there's any questions, email me, or I will try to have maybe a drop-in session this week as well, so you guys can drop in and answer questions, ask questions. Okay, so I will talk to you guys next class. Okay, take care. Bye now.